Okay, it looks like we are at 1/3 of the registered attendees, which is good enough. So let's start off with a gentle intro. Today we're going to be talking about how to visualize your node, how to monitor its progress and everything about statistics in a nice visual manner and not through reading the logs, which are clumsy and primitive and get out of date quickly because they scroll off screen and you can't really filter for what you want. So this crowdcast is actually a part of a bigger series that we are organizing on running your own nodes. We are big proponents of decentralization here, and there's no better way to decentralize than to run your own node at home. I actually don't recommend running your node in a cloud on AWS and something like that. And I recommend using solutions that you can roll at home. One of those is the Avado device, which is kind of a plug-and-play device, which you just buy. It spends almost no electricity. You plug it in, and it just works. And it'll sync up your node. It'll run it for you, and then you can also even open it up to connecting from others, so that others can connect to your node and use it in kind of this simulated cloud. So all the nodes participating in this will join in and participate. But the problem there is that if you've got a lot of calls coming into your node, like a lot of people querying it for applications and whatnot, a lot of people issuing transactions or just reading the state to find out what a certain balance is or whatever, your node might get overloaded. And that's especially troublesome if you're running a validator, because when you're running a validator on the Kusama network, you actually are at risk of your node crashing and going offline. And if you're offline, you're missing out on some profits, right? So you want to have a good monitoring solution in place so that you can keep an eye on everything that's going on with your node, and so that you can react promptly, so that you don't have to kind of manually check in with the logs every now and then and see if everything's fine. So first, I'll have a brief introduction into just monitoring in general and what we'll talk about today, and then we'll go to the other stuff after this theoretical part. So node monitoring like a boss. This is me. I'm a technical educator at Web3 Foundation. My name is Bruno, and my last name is pronounced Skvorc, like sh plus quartz. You can find me on Twitter at Bitfalls. Bruno ID is my website, and you can always email me at bruno@web3foundation if you have any questions about today's crowdcast or any other crowdcast that I've had in the past or will have in the future, or even content that I've wrote at the Polkadot wiki or whatever else. So why visualization matters is a topic in itself, and it's very interesting to see the evolution of visualization over time. Visualization wasn't really popular until the 19th century, actually, because there weren't actually many people who were literate at all, let alone mathematically literate, let alone capable of presenting data in a way that wasn't just a number on a page. So the first notable use of visualization was during the 1855 cholera outbreak, when John Snow actually had the idea that the infection was spreading through water, but there was no proof for it, and germs weren't discovered yet. So what they did was, what he did actually, he mapped the deaths on a map of the city and stacked them per household. As you can see in this right image, which is zoomed in on the left, zoomed in from the one on the left, you can see that the most deaths occurred near the pump. And so this was sufficient evidence to prove that the pump was in fact infected and leading to these deaths. It turned out that this one particular pump had cadavers or whatever inside and was spreading cholera, and everybody was getting sick from this one, while all the other pumps were causing no fatalities, almost no fatalities at all. So that was the first notable use of visualization, and it had a pretty profound effect on everybody involved, and all the, like, a bunch of new laws went into effect and so on. Then you have the Florence Nightingale rose diagram in 1858, where she visualized in this like improvised rose diagram the cause of death for soldiers. And it turned out that the vastly major cause of death was actually preventable disease. That's the blue part. The red part is wounds, and the black part is everything else. And so when she showed this to the queen or whoever was in charge of making changes back then, This actually resulted in a bunch of upgrades, hygiene and germs and medicine and just taking care of people and so on, and deprioritized protection from, deprioritized basically war spending in an effort to curb the actually preventable diseases. So visualization had its history in in the 19th century. It started making a mark, and it started changing people's life, because when you can visualize data, when you can see it in a more humanly approachable way, when you can kind of in a way that we're used to, you can kind of see it and intuitively understand what it's trying to tell you without having to do calculations, it has a much more profound effect on you. So we're going to be talking about Prometheus today, not this Prometheus.io, which is an awesome tool for exposing metrics. So Prometheus is actually kind of like a data storage server. And the tool that you're using, and sorry, I forgot to mention something. If you have any questions, please drop them in the Ask a Question box below in the Crowdcast UI, and I'll get to them as soon as I get out of full screen and can see them. And I'll make a break every now and then and check the questions so that I can address them as the presentation goes along. So we'll be using this Prometheus software, which is a tool for grabbing some data from a software, from another tool, and storing that data on disk. And this data is structured in a specific way that is then easily graphable and renderable if processed properly. Now, Prometheus just picks up this data from a tool that exposes it. So, for example, Substrate, which is the framework that Polkadot, Kusama, and all the Substrate chains are based on, exposes some of these Prometheus metrics in the code so that they are automatically readable by a running Prometheus program. So Prometheus is a program that you run on your computer beside the node. And that program will be reading the metrics that are being shouted out by the node that is running. So Prometheus picks up these metrics that are being screamed out into the ether by that node, who has these metrics that you need to watch. Prometheus then saves them in a local database and keeps them there for a period of time that can be configured in the options. And then Prometheus packages that data up and serves them to other tools that need to consume this data to produce reports. Now, reports can be visual, text, or anything in between, but Prometheus is in charge of just grabbing this data and configuring it so that it's easily consumable by other tools. It also has some alerts. So there's this alert manager tool, which you can install as an add-on for Prometheus, which will trigger specific outgoing hooks when things happen. So for example, if I say, give me an alert when my CPU spikes over 80%, or when my node is using over 80% of my CPU, then I can hook that alert up to any of my chat programs, SMS, email, whatever else I have for panic monitoring, so that I'm immediately alerted when that happens. So for logs, do not confuse it for a program that does logging, that just stores text data. This is not a searchable database of logs. This focuses on values across time. For logs, you should probably be using something like the ELK stack, so Elasticsearch and Kibana and whatever else goes in there, so that you have this fully searchable text database of logs. And those can be useful. You can aggregate across incidents, you can find out when something happened, and so on. But those are not metrics. Those are logs. So you find out when an error happened and why, or when an access to your system happened and why, and so on. For metrics, you're actually more interested in progression of data over time. You're interested in how things were going and when things went wrong and in what way, so that you can easily debug the issue, the cause of this change that is unwelcome. So Grafana is a tool that's going to grab this data that is neatly packaged and exposed by Prometheus, and Grafana is going to visualize it for you. It's going to show it to you in pretty dashboards and in pretty graphs, so that you can intuitively see what's wrong, what's right, and what you need to pay attention on. And Grafana focuses solely on that. So amazing visualizations that perform really, really well, and that you can compose and customize very easily. You'll see. So it comes with high-performance presets for showing that data. It has a bunch of graphs that are pre-created in the software. And Grafana is, again, another software that you run besides Prometheus and your node. You're usually not going to want to run all three on the same machine. Your node is probably going to be remote somewhere, and Grafana and Prometheus are probably going to be on the same server somewhere else. Another advantage of this is that if your node exposes these Prometheus endpoints, then you can also share your Prometheus endpoint with somebody else who maybe has a better dashboard, maybe is a Grafana expert and can make a better dashboard for you. So Grafana comes with these high-performance presets for showing that in the browser. You get a dashboard in the browser, so basically you can open it on your phone, on your tablet, on your huge screen TV, on a background projection at a conference. Who cares, you know? But it performs really at an arbitrary number of dashboards of charts on the screen, and those charts do not slow it down. That's the big deal there. So it also has alerts and can alert you to some changes that are unwelcome, but these alerts are more graphical in nature. So you're going to be seeing flashing lights on the screen and red text or red sirens and stuff like that. So it is wickedly custom. You can literally put any value into any format and graph it any way you see fit, if it makes sense. You can map it across time. You can map absolute values. You can make instant values at that moment in time. You can compare across periods, like how did it compare to past week's CPU performance, stuff like that, as long as you keep the data around for that long. So the flow is from tool to Prometheus to Grafana. That's how the data is here. So that's what we're going to be focusing on. We have a tool which exposes metrics for Prometheus through some configured options and settings in the tool itself. Then we have Prometheus, which grabs that data from a common endpoint and saves it in a database, and then packages it up nicely so that other tools can consume that data. And we have Grafana, which will consume that data and present it in neatly packaged dashboards, which we are going to demonstrate. That's it for this short presentation. Let's get into the technicals. Are there any questions? Yes. Okay. Oh no, I didn't share the screen. Oh my goodness. Hold on. Let's go through this real quick again. I'll just fly through the slides. So sorry. This is the benefit of having Crowdcast in another screen. Let me just pull that on to the side so I can see the chat more actively. There we go. That's going to work. All right. So here we go. Node monitoring. That's me, technical educator. Actually, this is going to be recorded, so don't bother writing this down. This is the map that I was talking about. So this is the map on the left side, and on the right side is the zoomed in version. So this is when Jon Snow marked the deaths per household in that neighborhood, and you can see that they are, that there's a lot of them around the pump. Florence Nightingale's flowers. You can see the blue area, the black area, and red area, and the effect from April 1855 to March 1856, and then 1854 to March 1855. These are direct comparisons, so you can see that the effect was decreased dramatically. So Prometheus, it's a tool, software exposes metrics. Prometheus picks these metrics up. Prometheus saves these metrics in a database and then serves them to others. It has alerts and it's not for logs. Grafana grabs some neatly exposed data. It comes with high-performance presets for showing that data, has alerts, it's very custom, and this is the flow that I mentioned. So you can see here that we have from tool to Prometheus to Grafana, and that's what we're going to be focusing on now. So we actually have a guide. Actually, let me address these questions first. So I hope the screen share was, hold on. I hope that screen share was fast enough. You can replay it by watching the replay later if you want to see something else from the presentation. Sorry about that. So how is Prometheus different to Grafana? So this is exactly something that I just covered. So basically, Prometheus stores data and saves it in a database. It can render it visually. It's not as pretty, and it doesn't have that much customization. It supports querying that data and showing it in simple graphs, but it specializes in saving it in a way that other tools can grab that data and then present to other visual tools. So Grafana is the visual tool that parses Prometheus data. Okay, so we actually have a tutorial on visualizing node metrics, and we're going to go through some part of this here, but there are some caveats that you'll need to be aware of, and it's not exactly as complete as I would like it to be, so I'll take you through it. You can find this tutorial by going to substrate.dev, and then just using the search bar to search for visualizing node metrics, or by visiting this URL that I'll put into the chat right now. There you go. So you can use this URL to find this tutorial. It's very basic, but and it has some caveats that we'll need to take care of, but it'll help you get started. So first, like I said in the presentation, you'll need three things. You'll need the node binary that's going to be running. So you basically need a Kusama node in this case. We'll be demonstrating this on a live Kusama node. It is not fully synced. It is only partially synced, but it's good enough for our visualization. We are then also going to need Prometheus itself, and we're also going to need Grafana itself. Now, both Prometheus and Grafana have downloads ready for you. So for any system that you're using, you can download a ready-made binary. You don't need to compile anything. Same for Prometheus. So you have all of these binaries ready. When you want, you just grab them, you just download them. If you're installing them on a remote server, you can do that as well, from source or from binaries, doesn't matter. So both of these websites, so it's grafana.com and prometheus.io, both of them have their download section. You can grab them from there, and the installation process is pretty seamless, even for Windows, which I'm using here. So we need a node, and I'm going to show you this node here that I have. Let me just kill this first. I'm working on something. All right, so this is my node. Can you see the screen? Is it readable? Let me know in the chat. Cool. All right, so I'm in my Polkadot folder, and you get Polkadot by just doing git what something's wrong with this terminal. Yeah, screencasting and a lot of tabs open for this little laptop. It's a recipe for sluggishness. Okay, all right, come on. Come on, buddy. Okay, there we go. So to get Polkadot or Kusama, which we're going to be running here, is very simple. You just go to git clone https. It's github.com/directly/Polkadot. And then once you're in there, you issue, so see we're in Polkadot. Once you're in Polkadot folder, you issue cargo node release. And that's going to build the binary. That's going to build the actually runnable software that you can then run as the node that you need to run. I do not know why this is so slow now, so I'm going to cancel this because my bad. But if you're interested in running a full node, we have a full node tutorial, and one that actually comes with quick install instructions so that you can use them very quickly, get up and running very quickly. So just follow this tutorial for some quick guides on how to get your node up and running. It's going to take a while for it to sync, but like I said, you don't need to have it synced to try this out. It is going to take a while for it to build if you're building from source, but this tutorial also comes with downloadable binaries, which you can just download and run, so you don't have to build them from scratch. So to get this recovered. Okay, it did. So to start the node, we just run it with target release Polkadot, and then we need to add some flags. So RPC cores all flag will allow everybody else from outside, so external machines, to connect to our node. This will also open the RPC connection so that they can actually query RPC. RPC is the interface for asking for data from our node. And this RPC external flag makes that possible. And the name is there so that you can see your node in the Kusama, in the Polkadot telemetry. So the telemetry screen is just a special screen, a special dashboard where all the nodes currently participating in the ecosystem, currently syncing with the network, are listed. So you can see your node there. So if we run this, you can see now that it is, oops, all right, lost focus. You can see now that it's starting up the node. Of course, there's a bunch of warnings and such. I don't know why this is so slow. Something's choking my machine. Ah, this thing. Okay, there we go. So now you can see that this node is synced up to block 78,000. It's not even nearly fully synced. Like the highest block right now is like 1.9 million. But this is enough, right? So this is syncing right now, and it's downloading blocks and it's doing things. It's producing things. And while it is doing this, it is exposing. See here, Prometheus server started at this port and this address. And we can actually check this out. So this is where the metrics are being exposed. So if you now go to localhost 9615, this is the endpoint. This gives you nothing because this is being read by Prometheus itself. But you can see if you add metrics to the end of this, you'll see which metrics exactly the node is exposing. There you go. So this is not exactly human readable if you just look at it in the browser like this, but it gives you a good indication of what our substrate node, our Kusama node, is telling the world about. So they're very, like, for example here, the lib peer-to-peer network is currently syncing in 31 kilobytes and out 16 kilobytes. You know? There's a bunch of this stuff here that you can inspect and see here, like it's downloading at 35 kilobytes, it's uploading at 22 kilobytes. So this is like the metrics that it's exposing, and this is what Prometheus needs to be able to fetch this data from the node itself. Again, this is the current data at the moment when I open this metrics. If I refresh this, the data is going to be different. So if we see here Polkadot load average over 15 minutes, let's actually see something more transparent. Network per second bytes, 35 kilobytes. If I refresh this, there you go. Now it's 9 kilobytes. So it changes, it varies. This is only the current snapshot. But Prometheus will take this snapshot every time it changes and save it into the database. So every change, all of this will be logged into the database in Prometheus. Okay, so that's 9615. Now, we need Prometheus also, we said. So I have Prometheus installed in another, there we go. It's installed in another folder. And Prometheus comes with its own configuration file. That is the sample configuration file. And that is the prometheus.yaml file. So if you see the Prometheus YAML file, it's pretty huge. It has a bunch of this configuration in there. So we don't need all of this at all. We can actually remove this YAML file, and we can create our own Prometheus file. And I will put in the content from this setup. This is the basic example setup in the tutorial. So here we go. This configuration tells let me just zoom in here. This configuration that we're going to paste in tells Prometheus this job, this crawling job, because this scraping job, because Prometheus is actually scraping your endpoint. It's constantly polling, it's constantly asking that endpoint for new data. This job is called substrate node. It's going to do this every 5 seconds, and that's frequent enough. And it's going to, so the static configuration is just some values that it needs. In this case, the target will be this URL. and that's our metrics endpoint. So this is the localhost 9615. That's the same thing as 127.0.0.1.9615. It's going to be fetching the metrics from this information. So we copy this and we can put it into this clumsy Windows copying. All right, let's do this. Fix. All right. And should need some IDE for this. But there you go. Okay, so this is good enough. The hatches are comments, so this can be ignored. So if we save this, and now we have to run Prometheus, right? So we'll execute it from the same folder, and we'll pass in the config file flag so that it knows which config file to read from, and that's going to be our Prometheus YAML file that we just wrote. And now it's reading. That's it. That's all you had to do. Now Prometheus is constantly listening for new data from this one, from the node, and it's saving it in the database. You can actually see this in action by going to the URL that it announces at the start when you start it. It's the address 00009090. That's also localhost or 127.0.0.1.9090. And we can check this out. I think I have it open here somewhere. Yeah, there we go. All right, so if you open localhost 9090, next time I'm crowdcasting from my gaming rig. This is terrible. All right, there we go. So this is the Prometheus basic dashboard. Wait for it to load. There we go. Okay, and now you can have the console here where you can just test for values. You have the alerts here. You can define the alerts that I mentioned before. Okay, no alerting rules defined. Nothing there. All right. And you configure alerts in the configuration file, actually, not in the UI. There's a status where you can read some information about it, targets, and so on, so that you can configure it to external targets, which you will see in Grafana when we do that. Okay, so you can see here that it's reading from the instance 1 to 7, and its job is substrate node. Last scrape was this, and it's taking 9 milliseconds per scrape. This is very slow. It's usually microseconds. I don't know what's going on with my hard drive today. So we can go back to the graph, and the graph lets you query some data from the database that's already been saved. Now, since this has been run for a pretty short time, we're not going to have much to see, but we can test it nonetheless. So here are all the metrics that it sees from that metrics endpoint. So it just categorized them here and just rendered them out here for easier selection. And now if I grab, for example, CPU usage percentage, and execute this query, I'm going to get 12.88%. That is the current CPU percentage right now, the last red value. And I can graph this by, you can see here, it automatically graphed it for me. So there's this rudimentary graphing mode in Prometheus, which will let you graph across time. And then you can pick the time frame here, 30 minutes or 15 minutes and so on. And you can pick from when until when. So it's fairly easy to see the movement of the CPU usage. So it went from, you can see here, it went from 12.3 down to 10%, up to 13.4%, and so on. And that's just over the past 2 minutes. So this is the resolution. How often do you want to, like, how frequent data points you want there to be here, and you can like flatten out the graph a little bit by increasing these data points. By increasing the resolution. Anyway, that's all that Prometheus can really do. You can also add more graphs for other metrics. Like there's a bunch of other stuff that you can do, database cache bytes, whatever. And again, you get this value. You can show it as a graph. Again, you can also configure kind of like a mini dashboard here. But as you can see, it's not very readable. It's fairly difficult to get around through, and it's not exactly the most optimized UI. There's an experimental React UI, but React being what it is, it'll perform worse than this hacked together JS. So I don't really recommend using it. It's a little nicer, but it's still not as fully featured as people might want to have. So this is the new React UI. You can see that there's some layout issues as well, but it's basically the same thing. It just uses components. All right, so now we have Prometheus set up, and it's reading data from our node, which is constantly feeding it in real time. So this is reading and writing data, and the node is just pushing it in as it's downloading blocks and trying to get in sync with the rest of the network. Now, on to Grafana. Grafana is installed, and actually, let me check. Are there any questions for up until this point? No. All right. Everything clear. Cool. Okay. So Grafana, when you install Grafana, it is mostly installed. People like to install it as a service because it runs in the background and it's constantly available. It's like a web page that's constantly running, like a web server, and it's serving itself. So you can always access it. I did it on my Windows rig that way, but you don't have to. You can run it manually as well. You can download it. The installer will ask you how you want to install it and so on. Just pick the latest version, no need for nightly builds, it all works really well. And then that's going to default to localhost or 127.0.0.1, port 3000. I changed this. You can change it in the configuration of Grafana in its folder. Depending on your OS, the documentation will explain everything if you want to change the port. So I changed it to 3500. When you start with Grafana, it'll ask you for username and password. Username and password are admin. And once you log in, it'll ask you to change that password. And the next screen you see is going to be this. So you have installed Grafana. Actually, we have data sources here, so I'm going to remove it so that I can show you how it's done. Okay, so the home page now will guide you through this basic setup, this onboarding process for Grafana, which will tell you to install Grafana, then add a data source, then add a dashboard, then add users, then explore plugins. So the Grafana ecosystem is immense. It has hundreds of plugins that are amazing, truly incredible visualizations of things. And one of the key selling points for me, at least, is being able to share dashboards. So you can upload a dashboard setup, because a dashboard setup is just a bunch of JSON configuration. You can upload that online, and anybody else who loads that in immediately gets your entire dashboard setup on screen. And you can add those screens to an existing screen that you have, so you can basically merge dashboards as well. And you end up with this very rich tapestry of data exactly you want it. And you can then customize each individual entry and then share that further. It's really, really well done. So first, we need to add a data source. Right now, Grafana has no idea where to read data from. So let's add a data source. And without clicking through the wizard, you would go through configuration, data sources, and then in data source, add data source. There are a bunch of data sources that you can use. So Grafana can parse a bunch of different types of data, depending on how it was aggregated, but we're going to be using Prometheus here in this case. So now it added a Prometheus instance, and it's going to use some default values. So it'll suggest here localhost 9090, which is indeed our Prometheus instance. We will use a get method and a 5-second interval. And that's basically it. You have just configured a data source so that Grafana knows where to fetch the data. Let's save and test. Oh, sorry, you need to put the seconds here as well. Okay. Save and test. Come on. Okay, data source is working, that's good. Now, if we go back to home, our wizard will tell us to add a new dashboard. So the tutorial that I mentioned before actually links to a dashboard that you can use, and that's this basic one. So you can see here that this dashboard has node memory usage, node CPU usage, height of the chain, and best finalized and sync target blocks, download speed, upload speed, number of transactions in the queue, if you're using it to shoot out transactions. So for example, a wallet provider will be making heavy use of this screen, and number of network gossip peers. So that's everybody you're connected to, how many other machines you are connected to. So there is a kind of like the repository of all Grafana dashboards that people have shared. And this one is shared here. So this is all dashboard substrate node metrics, it's called. And there's a screenshot you can see if you visit it, that's it. And all you need to do to use this is, you can see here, get this dashboard. All you've got to do is take this ID. So 11784, that's all you need. And now let's see how that works. Where was our, this we do not need. Okay, so new dashboard. Again, you can manage the dashboards and then new dashboard. Same thing as in the wizard at the start. So new dashboard, oh, sorry, no, we need to go to, where is it? Manage dashboards, import. So we can import a dashboard. So you can upload the JSON file. You can also download the JSON file for this template as well, download JSON, but you don't need that because you would need that if their server wasn't available, or if the dashboard isn't hosted on this package manager, then the JSON files come in handy. But when it's hosted on this, it's fairly easy and it's much easier to just grab the ID, 11784. So we put it in here, 11784, that's it, load. You can see here that it immediately imports the name, substrate node metrics. We'll put it into general folder because that's how you categorize your dashboards. You can have like hundreds of dashboards here, and then you put them into folders so that you can quickly access and change between them. They're very quick to load and change. So actually having a lot of dashboards is a superpower here. It's not it doesn't slow you down. And you can change it to a unique value because dashboards have to have unique values so that you can address them in the URL and link to them. And of course, you need a data source. We'll put Prometheus. That's all there is to it. So now it's loading. It's fetching. It's fetching the JSON, and the JSON will turn into graphs and dashboards on the screen. There we go. Okay. So now this is reading from Prometheus, but for some reason, we have no data in the memory usage or any other chart. Right? It doesn't look anything like the thing that we saw here. And this is because this is the substrate node metrics and not Kusama node metrics or Polkadot node metrics. So let's try and fix that. Let's go to each graph. You can go to edit. And so this takes a little bit of time of getting used to. I really recommend you read the docs and find out what each option does. But also, there's nothing you can break by tweaking these values and by changing them like randomly and seeing what happens. So feel free to look around. So now we have here metrics, substrate memory usage bytes, and for some reason, this metric is not producing any data. So let's try this. This field here has autocomplete. So if we search for memory, let's see what it gives us. Polkadot memory usage bytes, right? So we need to rename every substrate, every word substrate into Polkadot, and that's going to give us our metrics. As soon as you click this, it's going to load the data from the endpoint that you used, and there you go, we have it. So node memory usage now has the data. Just getting out of this, and you can already see that the graph is working. Let's do the same for node CPU usage. So we saw that we have here Polkadot, enter, and the CPU is rendered. Height of the chain, again, Polkadot. something's wrong here. So let's see, block height, Polkadot block height. Okay, so this is a different name of the entire metric as well. So this changed in between when the dashboard was published and now. Okay, so we've got this too. Networking bytes per second, that's the download and upload. Come on. The UI is hung up. Okay. Oh God. What happened here? Please buy me a new computer, guys. Change to Polkadot, switch, and boom, we've got a download and upload. All right, it's looking better. Now, number of transactions in the ready queue. That's if you're a wallet provider and if users are using your wallet or your node to push transactions to the blockchain so other nodes can pick them up and process them, you are going to have this queue at more than 0. Of course, since we are not even synced yet, we cannot have any transactions in the queue. I mean, we could, but they're going to be discarded immediately because they're going to expire before we synchronize with the network completely. So we have 0 transactions in ready queue, and then we have the gossip peers here. I clicked. There we go. Okay, substrate peers count. Let's see, peers. Okay, so now this is a little different. Let's see this one. Polkadot sync peers. So we are currently syncing with 24 other nodes. Weird, that seems high. But okay, maybe during the sync. Okay, so now you can see that our graph has not moved at all. And none of them have moved at all. They're still at the value that we've originally set up. And this is because there's a refresh here. So you can click the refresh and now it's moved. But you don't want to keep clicking refresh, so that's why there's an interval here. Have it on 5 seconds, 10 seconds, 30 seconds, or much longer, depending on how much bandwidth you're ready to sacrifice on this, how powerful your computer is, how much movement you want to see on the screen, how much you care about the data being up to date or just relatively recent, and so on. All right, so this is almost it. This is all you need to set up Grafana, Prometheus, and your node. And when you're running your full node, I highly encourage you to run Grafana and Prometheus on either the same device that's running the node, because they're all lightweight, or because there are ARM builds for each of these tools, for Grafana and Prometheus, which means you can run them on ARM computers like Raspberry Pis or Nano PCs, or even like this thing. This is an F-secure computer. You'll find these at, it's called the USB Armory MK2. And so this thing can also run a bunch of this stuff. It's designed for security, so it's designed to hold validator keys and such, but it's perfectly adequate as a mini computer to run this sort of stuff. So I recommend running this on a microcomputer and having it accessible on your local network so that you can run it on a separate screen, tablet, somewhere in a dashboard where you can keep an eye on your node, especially important if you're going to be running a validator. Do not rely on logs and do not rely on, periodically pinging the server to find out if it's alive. Make sure that you have all of this active, because this is what can make the difference between life and death, or between profit and loss during validation. You can see here that memory usage is going up and down, and the scale is configured to be relative to the range that it's looking at. So this is relative to 310 and 334 megabytes, because that's what the range was between the past 4 minutes. If this node went to 2 gigabytes, then the range would also change, and it would present it that way. So you could actually change this node memory usage graph and have it use a different minimum and maximum. So visualization, and so now you have here the axes, and so you can define all of your minimums and maximums here. So if you have the y-axis, you can use the y minimum. So it's at auto, and I think I can just punch in this 2000, see what happens. It went off the charts somewhere. Let me try this, 100. God, this is so laggy. Yeah, I don't think this is, okay, there we go. So, yeah, so it needs okay, so it did decrease from 0, hold on. So you can see that it's now always above 0. Now, if you increase the maximum, which should work, but it doesn't work on my laggy machine, if you increase the maximum, you should be able to see the memory rising over a period of time. And this will alert you when, for example, there's a memory leak, which was an issue relatively recently. When you see your node's RAM rising in value consistently and not dropping at all, you can basically estimate when it's going to crash. So while there are different ways to kind of set up your node to auto restart after a certain RAM usage, it's definitely better to keep an eye on this and to be aware of when it's getting out of hand. So thank you, Masay. See you next time, and I will, just to finish it up for everybody so that we don't go over time, I will add a new chart here. Let me first disable the refresh interval because it seems to be completely choking my computer. Can't even set it to off. Okay. So you add a panel by going to add panel, simple enough. And I really encourage you to explore all of these options. There's literally nothing you can break. So you choose a visualization if you want something like that, and then it's going to offer you a lot of awesome graphs that you can choose from. So let's pick a gauge. Right now it has no data. So, okay, we have a gauge. Now let's see if we can present the CPU usage in a funky gauge. Let's search for CPU in the metrics, Polkadot CPU usage percentage. All right. Now let's put it to, let's just press enter so that it loads. And now it's at 10. But this is kind of flat. Let's visualize it better. So let's put it to some more thresholds. All right, so let's say that everything from 50 to 90 is yellow, and everything above 90, actually everything above 80, let's put it to be red. And the base is green. The minimum is going to be 0, the maximum is going to be 100. The unit is going to be a percentage of 100. And there you go. So now we have a gauge, and that's it. You can just jump out of this and you have it. So we now have the CPU usage. We could have put the label here for CPU and so on, but it doesn't matter. We now have a gauge which will show you how much of your CPU is being used. Let's refresh and see if this is changing. Still at 10%, 10%, 10%. And that's because every 5 seconds, the metrics change. Right? So this is still at 10%. There we go, 11% now. Now, you can see here, you will immediately notice when it turns yellow, and then immediately when it turns red. And so you can react promptly when you see changes going on that you don't want to happen. And that's basically the biggest benefit of Grafana here. It's visualizing what can go wrong and when, and alerting you in time. Now there's a bunch of other stuff. There's alert rules. Yes, a dashboard. You can also save the dashboard and then re-export it so that other people don't import the outdated dashboard so that it actually works for people. Let's save it. Let's just save like this, and then it's saved. There are alerts you can set up so that it notifies you through some notification channel. But something that I'm very excited about is in fact the Explore tab. No, sorry, not the Explore tab. Where was that? Plugins. There we go. So on the plugin screen, you get a bunch of plugins that you can use, and these add new visualizations, new data sources, new types of using the data, new queries, a bunch of stuff. You can find more of them on grafana.com, their repository of plugins. And I really encourage you to play around with these and share some dashboards with us, especially for the Send Nodes competition. If you want to join and run your own node, please visualize, configure a Grafana endpoint, and share your screenshots of the Grafana dashboard that you've set up. Put them on Twitter, and we'll reward the most creative ones. Thank you for watching, and I'll answer some questions before the end, before we sign off, if there's anything people are curious about. All right, seems like no questions. So please remember, if you get stuck on any of this, message me, find me on Twitter, on email, on Riot, wherever you want. I will do my best to help out and jump in and help you configure things, and we can get the ball rolling on custom metrics and beautiful visualizations. Monitor your node like a pro, not like a savage. Thanks for watching, and see you next time. Bye, guys.